Hi everyone, welcome to the video on the integration of circular functions. Hopefully this will be a fairly straightforward couple of videos to get through, and hopefully you'll be sort of fairly familiar with the process that we're going to go through. Ideally you will have been through the differentiation of circular functions, so then we can anti-differentiate with ease. So when we do the integration, remember that it's just the opposite of differentiation. So when we differentiate, sine becomes cos, and cos becomes negative sine. So we're going to do the opposite there, okay? Sine is going to become negative cos. I'm going to just leave a little bit of space there, okay? Because normally when we would differentiate, we would take the derivative of this and put it at the front. But instead of multiplying by that derivative, what I'm going to do this time is I'm going to divide by it. So it's negative 1 over k out the front of cos. The part in brackets there is going to stay the same, so it's just kx plus a. And then because we've anti-differentiated, we need to remember to also put the plus c on the end. And it's going to be very similar with the cos function. So, normally when we differentiate, cos becomes cos becomes negative sine. So when we anti-differentiate, then cos is going to become positive sine. So that's going to be sine. The part in brackets is still going to be the same, but I need to remember to divide by the derivative of what's in the brackets there, and that's just going to be 1 on k again at the front. I could instead just write the whole thing divided by k if I wanted to, but I think this is a more common way of writing it. And again, remember to write the plus c on the end. So those are the rules that we're going to use for anti-differentiating these trig functions. And if we have a quick look at these, evaluate these integrals. So the antiderivative of sine 2x, well, when we anti-differentiate, sine becomes negative cos. So it's going to be negative, I need to divide by this, so it's going to be negative half out the front of cos 2x. And then we also have to have that plus c on the end. And that's as far as we need to go with it. It's really just like that. The next one, we've got these terminals, the upper terminal of pi on 2 and the lower terminal of 0. So, anti-differentiating this. Now the 3 can just be moved through the integral sign. We don't need to do anything special with that. So, I'm actually just going to write that out the front and then deal with the integral after. So, the 5 would need to make it 1 over 5. Cos becomes sine when we anti-differentiate, so it will be 1/5 of sine with the 5x plus pi, and that's between pi on 2 and 0. Well, I'm just going to keep on carrying that 3 through all the working, so it's 3 out the front of, now I first sub in the upper terminal, so it's 1/5 of sine, then it's going to be 5 pi on 2 plus pi, and then I need to take away 1/5 of sine out the front of 5 times 0 is just going to be 0, but then we have to add on pi, so it's just pi there. And so figuring these out, we can have 1/5. Now this is sine of 7 pi on 2, and sine of 7 pi on 2, if we think about the unit circle, I'm just going to draw the axes there. There's pi on 2, 2 pi on 2, 3 pi on 2, 4, 5, 6, 7 pi on 2 is down here, and the sine value there is just negative 1. So it's 1/5 times negative 1 minus 1/5, and sine of pi is over here, which is just, well, 1/5 times 0. So that's going to be nice because that term there just disappears. So we've got 3 times 1/5 times negative 1, or 3 times negative 1/5, which is just negative 3/5. Well, that's about it. We'll leave the video there and we'll do another example in the next one. I'll see you later.